Hi, welcome to this video looking at the higher tier for May 30th and May 31st for the 5 a day. Okay, this is from the old specifications, so it's from the GCSE starting G grade, but it's still appropriate, okay, for higher tier students doing GCSE 9 to 1 maths. Okay, it's an extra bank of questions, okay, on the old spec that is still appropriate, okay, and some of these questions may also be appropriate for the foundation tier, but it's aimed predominantly at the higher tier students, okay, so students doing higher tier maths for AQA, OCR and Edexcel, okay, and all other international and appropriate examples for GCSE 9 to 1 maths, okay. As ever, please pause the video, okay, try the questions yourselves, and then press play when you're ready. This is the first question. Simplify this surd. Well, what I do is I do 4 times 2, which is 8, and then I do root 3 times root 5, which I can write it as root 3 times 5 under 1 square root, which is root 15. So it's 8 root 15. So 4 times 2 is 8, root 3 times root 5, I can write it under a square root, okay, under 1 square root. Write it like this. Okay, 3 times 5, which is root 15, okay. Four 2's are equal to 8, guys, okay. So this type of question would appear on a non-calculator. Now I'm aware that at the time of obviously recording this, paper 1 is done, okay, but it still could appear on a paper 2 and a paper 3, okay, because it would probably ask you to write it in exact form, or if it appeared in a paper 2 or paper 3, it might say what's the numerical conversion of this, okay, but this is the exact form, okay. Next question, calculate the length of y. Well, it's an isosceles triangle, so that angle is going to be 70, okay. That angle is going to be equal to 30, okay, degrees. That's length of y. Now, there's one of 2 ways of doing this. I can use the sine rule and say, okay, well, y over sine 70 is equal to 8 divided by sine 30, okay, and again, this is something that would appear on a calculator paper, so please don't worry thinking, I've got to do this here off the top of my head, okay, sine 30, okay, rearrange to get y by timesing both sides by sine 70, so the answer is y is equal to 8 sine 70, okay, divided by sine 30, okay. I'll leave it in its exact form here rather than work out the calculator version, okay. But that's the exact answer, okay, for the value of y. Of course, you would obviously enter this in your calculator to work out the value of y, okay? But let's just actually work that out here, just in case here, if you're not happy with the exact version. Okay, so on our calculator, guys, we would type in 8 sine 70 or 8 sin 70, okay, and then divide that by sin 30, okay, which is equal to 15.04, okay, centimeters to 2 decimal places, okay, but obviously it goes on more than that, okay, it's 15.0350819327 on here. Okay. Right, guys, next question, solving a quadratic equation. X squared minus 13x minus 30 is equal to 0, so solve this equation. So factorising this, guys, okay, so it's a double bracket, okay, make it equal to 0. I'm going to put x and x in both, okay, because x times x is x squared, and then I want 2 numbers that add to give me negative 13 and multiply to give me negative 30. So I look at the factors of 30. Now you might have spotted it straight away here, so it's going to be minus 15 plus 2, okay, because minus 15 plus 2 is minus 13, or 2 minus 15 is equal to negative 13, and negative 15 times positive 2 is negative 30. Okay, so it's x minus 15, guys. Just obviously make it clear there's a minus there. Okay, x subtract 15 and x plus 2 equals 0. And you can check that by expanding the bracket. So your solutions are x is equal to 15, okay, or x is equal to negative 2. Okay, or x equals both. Okay, that's also correct. Okay. But provided that x is negative 2 or x is positive 15, okay, your answer will always equal 0, okay? Because by putting 15 into here, okay, I get 0 times 17, which is going to be 0. If I have a negative 2, I get negative 17 here, and then I get 0. Okay, anything times 0 is going to equal 0, okay, by definition. Minus 17 times 0 is going to equal to 0. Next question is looking at a reoccurring decimal. Write 0.12525252525 as a fraction. So I'm going to let here, okay, I might not have a lot of space here, so I'm going to try to make it a bit smaller. So let r equal to this decimal, okay, so let small r equal to 1252525, okay, and then it goes on forever. Okay, I'm not going to work out what 10r is. Okay, I'm going to work out 100r, and I'm going to work out 1000r. Okay, so it's 1.252525. Okay, and then 2, and then ... 100r is equal to 12.5252, and then 5, and then ... again. Okay, it goes on forever. Right, let's now work out 1000r. Okay, so that's equal to 100r, sorry. It's a bit like a small space here to work out this question. Of course, in the exam, they would give like more space to work this out. Okay, I'm going to get 125. Okay, 0.25252525. Okay, and then etc. etc. Okay, notice that I've obviously been writing it under the same like place value, because then it becomes clear now that if I look at this one here, so equation 2 and equation 4, okay, and if I do equation 4 subtract equation 2, so let's just put our answer down here, even though it's a different question, okay, we will get, on the left hand side, 1000r take away 10r is 990r. Okay, that has to equal 125 here, take away 1 is 124. The reason I know that is because after the decimal point, 2 take away 2 is 0, so that's going to knock each other out. 5 take away 5 is 0, so they're going to keep cancelling each other out forever indefinitely. Okay, for that. Dividing both sides by 990, I get 124 over 990. Okay, which I can simplify if I want. Okay, but I'm going to leave it as that, yeah, because I don't have much space here to actually simplify it. Okay, but I can divide top and bottom by 2, and I get 62, okay, over 495, yeah, if that makes sense, because half of 1000 is 500, and obviously it's a difference of 10 there, so half of 10 is going to equal to 5, okay, and then this should be the fully simplified answer, okay, and you can check that on your calculator. But that's how you convert reoccurring decimals to fractions. So make sure that you line up your place values after each after each part when you work out your R10 or 100 or 1000 or 10,000 or yeah, etc, etc. Next question, okay, I know there's not a lot of space here. Sketch y equals f of x plus 1, so the plus 1's outside the bracket, so it's going up by 1. So all the y coordinates are going up by 1. Okay. So it's going to look something, okay, like that. Okay, oops. Obviously, it doesn't look like that very well actually yet, but you get the idea. Okay, so it looks like that. Okay, all the y coordinates have moved up by 1. Okay, because it's outside the bracket. The plus 1 is a translation of a vector 0, 1. So it's 0 in the x direction and up 1 in the y direction. Okay, so it's going up 1 in the y direction. We're now looking at May 31st, okay, 5 a day for the GCSE 9 to 1 maths, okay. The first question is a tree diagram question, okay. A biased coin is flipped twice, tails and heads. Bias just means that it's not fair, so the probability of heads is not equal to the probability of tails, and that's actually visible because 0.8 is far bigger than 0.2. Okay, it's actually 4 times as likely to get a tails than it is to get a heads, okay, on this particular coin. Okay, work out the probability of getting a head and a head. Well, it's 0.2 times 0.2, which is 0.04. So it's 0.2, 0.2 times 0.2, which is 0.04. Okay. Next question. Work out the probability of getting 1 head and 1 tails. So it's going to be 0.8 times 0.2 plus 0.2 times 0.8. Okay, so let's just do 0.8 times 0.2 first, and then we're going to double our answer, because obviously it can repeat again in a different arrangement. Okay, that's going to equal 0.16, and I'm going to double my answer because that's working out tails then heads. Okay, but I can have heads then tails. That's 0.2 times 0.8, which is also 0.16. Okay, so I'm going to double my answer. Okay, which is 0.32. Okay, so make sure that you are happy with that, yeah, and make sure that you are always answering the question or questions on tree diagrams. Okay, so make sure that you read the question carefully. Okay. Next question, expand and simplify this double bracket. Well, I'm going to have x times x is 2x squared. X times negative 1 is minus 1x. Okay. 5 times 2x is positive 10x, okay, and positive 5 times negative 1 is negative 5, guys. Okay, so that's expanding the double bracket. The second part is to simplify, so collecting like terms, 2x squared plus 9x, because minus 1x or minus x plus 10x is plus 9x, okay, subtract the 5. Okay, or minus 5. Okay, I don't actually need the minus 1x there, but I was just putting it so it's very clear when I collect my like terms that I'm collecting these terms together. Okay, I don't need to actually put the minus 1x there, but I was just putting it so when I collect like terms here, it makes it a bit more clear and a bit more obvious which terms I'm actually collecting together. Next question, sketch y equals f of x minus 2, so it's inside the bracket, so it's not doing the opposite here, so we're going to add 2 to the x coordinate, so it's in the vector 2, 0, so it's a translation of 2 to the right. Okay, that's going to go there, that's going to go there, okay, 1, 2, okay, 1, 2, okay, 1, 2, so it's going to go somewhere here. Okay, that's 1 and that's 2. Okay, so it's a translation, guys, so it's going to go through these points. Remember that it's like a smooth curve. Okay, passing through those points. Obviously, I've done it freehand here, which you are meant to do it freehand, but make sure that you use your pencil here for these questions, okay, and then rub it out and then start again if you need to, okay. But it's a translation of 2 units to the right, okay. If it's inside the bracket, then it's always opposite the sign, okay. So x minus 2 means I move it 2 to the right. Rationalize the denominator, so I'm going to times top and bottom by 1, which is 5 plus root 7 over 5 minus root 7. Okay, so this is how to rationalize surds here in this form. Okay, the reason for that will become clear in a second, but essentially on the denominator, I have the difference of 2 squares, okay, when I expand the bracket, and on the top, I just have a surd. 3 times 5 is 15, 3 times root 7 is 3 root 7. On the denominator, when I expand and simplify it, I get 25, sorry, it should be a plus there, okay, plus 5 root 7, subtract 5 root 7, so they're going to cancel. Minus root 7 times positive root 7 is minus 7, so it's 25, take away 7, which is equal to 18. Okay, on the denominator. So we get the final answer of 15 plus 3 root 7 all over 18. Okay, and I can simplify that if I want by dividing everything through by 3, but it's okay to leave it like that, okay, as your answer. That's also fine. So just to be clear, guys, where did the 18 come from? So if I expand 5 minus root 7 and 5 plus root 7, so 5 times 5 is 25. 5 times positive root 7 here is positive 5 root 7. Okay, subtract 5 root 7, so they're going to end up cancelling. And then minus root 7 times positive root 7 is minus root 49, which gives me minus 7, okay, because a negative times a positive is a negative, so it becomes negative root 49, which is equal to negative 7, okay, on the denominator of my fraction, okay. So you can check by expanding this double bracket, okay, so you can check by expanding 5 minus root 7 and 5 plus root 7, okay. I appreciate that I have like jumped this step here, but I'm trying to class this as like a revision video, so hopefully you are happy. But if you do want like a more in-depth video, then please do check out the videos or video on expanding brackets involving surds, okay, or especially double brackets involving surds, okay. But it's essentially the difference of 2 squares, okay, when I expand the denominator of my fraction, and that's why I've done that, so I don't get a surd on the bottom of my fraction. Okay, rationalize the denominator means get rid of any surd or surds on the denominator on the bottom part of my fraction, okay, and that's how to do it, okay. So we times it by 1, in this case 5 plus root 7, over 5 plus root 7, okay. That's how I get my answer. Okay, right guys, that's the end of today's short, sharp video. I hope you found it useful. I hope you found it informative. If you did, please press like, please subscribe to the channel if you're new, and lastly, please click that bell icon so you don't miss out on further and future videos for this channel. Okay, but that's it for me today, guys. Thank you so much for watching. Take care, stay safe, stay healthy. Good luck with your revision and your remaining exams, okay, for post half term, okay, but I do hope that everything is going well actually during this half term, and I'll see you for the next video. Okay, bye for now.